Welcome. In this video, I want to show you then how to capture the material, the information that you put into the test program, and how to incorporate it into the Word file. The problem at hand was a turbine expanding water from a high pressure, high temperature at a given flow rate through an inlet area of 1 meter squared. The velocity then was determined to be that based on the density. The process went to a second state. It was steady so that the m dot was equal to m dot 1, stated that the velocity was constant through the system, so that velocity 2 is equal to velocity 1, a lower pressure, lower temperature, and the area ratio then would be the area 2 over area 1. Since area 1 is equal to 1, the ratio then is 209. We then went to the device panel, specified the input and the output states. We said because it was adiabatic that the heat transfer was equal to 0. And we were able then, in solving the energy and mass conservation equations, we were able to determine that the power output was 26.58 for the m dot given in the problem. By going to the I/O page and hitting super calculate, you then have all of the information. The top box here corresponds to everything that you put in the input. The two states are identified there, as well as the device. We had a single device, which was going from 1 to 2 with no heat transfer. Our output then is shown in the lower box, and the output repeats the input states as well as the calculated thermodynamic properties. And it also gives information calculated for the device panel. And the value that we're interested in here was the 26.59 kilowatts as the power output with no heat transfer. I've also brought up the Word file. And as we said before, the Word file is generically given by a certain title. The Word file is in landscape mode, and I want you to retain it in landscape. The first thing that we'll do is we'll click into the header, and we'll put in your ID number. I'm going to go ahead and put in my ID, and I'm going to then put in that this was problem 4, section 1, problem 53. And it also had an identifier. The identifier in this case was ORS. So then if we go back into the input area here, in order to get the information to be brought in properly, what I want you to do is I want you to go to this location here, put your insert at the here point, and then go back to the test and select everything that's in the test. And you hit a copy and then go back. And when you go to this point here, you want to do a paste special. And you'll be putting in unformatted text. And by doing this, then it will take the format that's already in the Word file and copy all the information to your Word file. We're going to do the same thing for the output. And in the output, we're going to come down here. We're going to bring in the output. We're going to do a copy. We'll go back here. The cursor is at that point. We're going to do a paste special. and we will then do an unformatted text. And so we now have the information that's needed for this particular problem. What I would like for you to do on your problems, before you submit them, I would like for you to highlight and bold the answer to the problem. And so the second part, we were looking for the area ratio, which is actually just equal to area 2, because area 1 was given as equal to unity. And we also were asked for the output power, and the output power was this number here, 26.59. And again, by highlighting it and bolding it, then you help to identify for me your answer, making sure that you know that this is why you did the problem. The other important thing is you'll see that your name will be included here, as well as the time, a timestamp on when you performed this particular problem. And so it's important when you copy your output that you copy this information to identify that it's your work and when you did the work itself. So now we have everything in the file. I want to start off with by doing a save as. And for this particular problem, I want to save it as your identifier, the problem number, again, which is 04, it's chapter 4, section 1, and problem 53, as well as the ORS identifier. And so I'm going to save that first of all as a Word document, and I'll tell you why. You want to go to a location in your network, wherever you have your information, and send that particular file with that particular name and save it. And now it's saved. And then you'll want to do one more step. You'll want to do a save as and go ahead and select as a PDF. And so it's going to have the same name, but it's now going to save it as a PDF. And so you'll export it as a PDF file. The nice thing about this is that you'll have this particular problem. You'll have this particular problem that you can reference later. As long as you've put it in as a Word file, if you wanted to redo the problem, you can go to this Word file, and I'm going to show you how you can actually import the information from the file into the test program. And that will be important because if you want to reproduce or redo a problem, you don't have to put all of the information back in. If you want to just change something, you can make minor changes. And so I'm going to show you real quickly. If I went back to the test file, and if I went to the test app here, and I selected that single flow again, and PC model, and the app, I'm now back at the beginning. And so I have no information. We can't save the previous problem such that it would come back directly into the program. However, one can go to the I/O page, one can go back to your Word file, and one can select from states and devices, from these curly brackets to the curly brackets, and do a copy. And so come back to here and just place that right into here. Paste it into there and do a load. And when you do the load, then what happens is it then brings everything in. And so the two states, the device panel, everything was brought in from the input data from that Word file. So that's a very powerful thing to have. You might be working on a problem, you have to go somewhere, as long as you save the information from the I/O panel to a Word file or a text file of any kind, you can then retrieve it and start back up at the place that you were before. And so that's very powerful. Before I leave, I did want to show you one other thing, and that is for this particular problem which once again was just a turbine expanding a high pressure, high temperature gas, high temperature, high pressure steam to a lower pressure, lower temperature through this device. If one went to the graphics panel, one could actually then observe on the TS diagram the two state points. And so here are your two state points. This is the input, this is the exit. You see the properties for the saturation line, and you also see the properties for those two state points. In this particular case, if you look, you see the entropy did increase a little bit. This was a non-isentropic process, and so there's some irreversibility associated with it, even though it was an adiabatic process. And so this thermodynamic plot, this temperature entropy plot can be observed. One could also look at the enthalpy entropy plot and the 2 points on that plot, as well as any of the other plots, depending on what you want to look at. If you wanted to look at a pressure volume, it will draw the dome as well as the location of the 2 points. And so that is, now that you've got your Word file set up and a PDF stored, all you have to now do is to go into Blackboard and upload that PDF to the problem at hand so that I can look at it and grade it appropriately. Okay, thank you very much. Goodbye.